it says, for each of the following triangles, write down the ratios for each of the given angles. Okay, so there's our first one. I'm just going to roughly draw it. You got theta up there in the top corner. And that's an F. Sorry, it's a bit of a shabby F. Okay, I'm trying. Alright, now, they want us to know, okay, what's sine and cos and tan of this angle up here. Okay, and it's super easy. Watch. Sine theta, cos theta, tan theta. Yeah.
Is there like a trick to do that? Because I always get it wrong.
Well, one of the helpful tricks is to know what, like, remember how I talked about all of these labelings, right? So if you can nail those, the rest of it just kind of falls out. I'll show you what I mean.
I'm talking about drawing circles.
Oh! Draw it on whiteboard.
It's so annoying.
Sorry.
Do we have to draw the circle after theta on?
Yeah, you should. Yeah, you should. Don't worry, you'll get the hang of it, trust me. After you've written a few 100,000 of them, it's second nature. Okay, now, I'm going to label all of these sides, 1, 2, 3, in relation to theta. Okay, the easiest one's the hypotenuse, because it's always the same. Which one's the hypotenuse?
F.
It's F, good. It's opposite the right angle, it's the longest side. So I'll just call this one hypotenuse, like so. Okay? E, over here. It's on the other side from theta, right? So it's opposite. Okay? And that leaves D, which is right next to the angle. So that's adjacent. Okay? So I would say sine theta, I'm going back to SOHCAHTOA now, right? Sine is opposite on hypotenuse. Opposite on hypotenuse. E on F. That's it. That's all it's equal to. Simple. Okay? Cos is SOHCAH, C-A-H, adjacent on hypotenuse. Adjacent on hypotenuse. D on F. Okay? By the way, please note, the order matters, right? Like, E on F is not the same as F on E. Makes a big deal, right? So it's SOHCAHTOA, not SHOHCAHTOA or something. You know, it's the order really matters. Okay,
So
yeah.
hypotenuse of opposite wouldn't be the same.
Correct. Yeah, because fractions. You know, for example, 1/2 is not equal to 2/1. Totally different things. Last one, tan theta. SOHCAHTOA, opposite on adjacent, opposite on adjacent. E over D. Now, that's it. It's really simple, isn't it? Here's what it looks like, and theta is in the bottom right-hand corner, and then you've got these two legs, 12. Now, it says, write the trigonometric ratio, which must be used in order to find the value of the pronumeral in each of the following triangles. Ugh, that was a mouthful, okay? Let's start with write the trigonometric ratio which must use. So, we're either going to have sine, or cos, or tan. That's going to be the answer, one of them, right? Depending on the information we've got. So, look at this, right? You got two sides, right? And the question is, which two sides have you got? 15, it's opposite the right angle. It's the longest side, so that's clearly the hypotenuse, right? Over here. Now, hold on. I don't have this side over here. What I do have over here is opposite, right? So you can see, that's the pair you need. Okay. Here's the equation you would write. We already worked out you don't need cos and tan, it's sine that we're after, right? So you'd write sine theta equals opposite on hypotenuse. That's 12 on 15. You can simplify that fraction, right? What does it simplify to? What's the common factor? Think? It's going to be, the common factor is 3, so it's 4/5. Okay, now, reach for your calculator now. Okay, I'm going to get mine out. The reason I knew that sine would be the one I wanted is because the two sides that I've got, right, in relation to theta, right, which sides are they, right? There's opposite, adjacent, hypotenuse, but that's 3. I've only got 2 of them, right? And the answer is, I'm like, well, the 12 is opposite theta. So it's the opposite side.
Why can't you write adjacent on the bottom?
Well, because I don't know what it is. So there's no point saying that's the adjacent side because I don't know its value, so I can't work with it, okay? Whereas I do know what these are. So I can write this down. Okay? Now, having done this, okay, you can see sine is sort of in the middle of your calculator. Okay? Now, just above sine, above the button, it looks like this. Okay, now this is so important, it's actually worth drawing the little button here and telling you what this is all about. Okay? That thing that's above sine, some people say this before. It's a negative one. And the way you read this is called sine inverse. Okay? So the easiest way to explain this is, you know how to square something, right? There's x squared. Well, the inverse of squaring something is to undo the square, you take the square root. Okay? If I had 5 and then I squared it, you get 25. If I take the square root, I come back to my original number. Okay? So what you've got here is sine of some number, the angle that I'm after, is equal to 4/5. Okay? Sine of that number. So to undo that, here's what I'm going to write. Theta equals sine inverse of 4/5. This line is really important and it's a bit weird. So make sure you write it down, okay? Cannot skip this, it's vitally important.
And you have to close the brackets.
Yes. What have I done? I want to get theta on its own, okay? So to get rid of sine, I use this sine inverse idea, okay? So this is what I'm going to do. I'm going to go to my calculator. Obviously, because it's above the button, I'll hold down, I'll press shift, okay? Shift, press the sine button, and you'll see the brackets appear. This will come up on your calculator. Right? So what you're going to punch in is 4/5, or 0.8 if you like.
Right, slow down, slow down, slow down.
Okay? So you press shift sign, right? And then this would come up.
Ah, yeah.
So now you can type in the fraction and then you can close the bracket. Alright, now, when you press equals, what happens? Let me catch up with you. Sorry.
53.130102335.
I'm just going to write that many. Okay, now what does this tell you? What does this tell you? Let's just round it off to the nearest unit. The nearest unit. So it's approximately 53 degrees. Okay. And what this means is that if you drew a triangle, right? And if it was right angled, and if you measured it properly and carefully, you made this side 12, you made this side 15, who knows what the other side is? Okay, you can go find out by Pythagoras if you want to. Okay? But the point is that when you draw that triangle, right? This angle over here is going to be 53 degrees. It will always be 53 degrees. It can't possibly equal anything else. There's no way you can redraw the triangle. It's always going to be equal to this. Okay? It's a little bit like, okay, if someone's measured my neck circumference and they've measured my arm length, okay? My finger lengths are going to be such and such. There's nothing else. It's conclusive, okay? So all this information over here, it's conclusive. This is the angle you end up with. And in fact, I'd actually love you guys to give this a go because 12 and 15, that's not too long. You might have a ruler there or you can borrow one off me, okay? There's a 15 centimeter ruler, okay? I want you to actually draw this out. And then I can give you a protractor. I have some here, right? And sure enough, you will measure and it'll be 53 degrees to the dot. You'll get your ruler, okay? Now, measure out your 12 centimeters. Now, I'm just going to say, suppose that's 12 centimeters. Okay, you've measured it out, that's great. Okay. Now, rather than draw the next one, the 15 centimeters, the problem with it is I don't know, like, is it up here or over there? What's the length that's going to be right? So here's the way I would encourage you to do it. Do the bottom one. Now, you don't know how long it is. There's no problem, that's okay. Just draw it really long. Right? No, just keep going. Longer than you need to, okay? Then here's the trick. You know that here's your right angle, okay? And your other side is going to be here or here or here or something like that, okay? So what you do is place your point up here and then rotate it like this until you get to 15 centimeters on your ruler, okay? So I'll show you again. So for example, I'm like, okay, suppose I'm here and I'm like, it's not 15, it's 11 or 13 or something like that. So I keep moving, I keep moving, I keep moving until, aha! I've got 15 centimeters now. and that's when you join it up. Okay? And then you can get rid of all these extra bits, and you'll have a 15 centimeters that's perfect. You'll have your right angle, and then you can get your protractor out and whack him in here.